Hey team, this is chapter 12, lesson 5, and today we're going to be learning to solve more complex geometric problems with 3D vectors. This is interesting, this is definitely interesting, but it's also extremely challenging, so let's get cracking with it. So what we've got is A, B, C, D, E, F, G, H is a cube. You can see it drawn there, it's a pretty scruffy drawing, but there it is, where the vector from A to B is the vector B. It's a good idea to pop that on straight away. A to D is the vector D. And A to H is the vector H. Make sure you get your directions on there, that is important. And we're going to be proving that the line, the space diagonal going from B to G will bisect the line going from C to H. Okay, now to do that we're going to need to invent a point where they meet, and I'm going to call that P. So if we're saying that BG bisects CH, we're saying that C to P to H must be in the ratio 1 to 1. Okay, they must be equal to each other. If I've got the line from C to H like this, for this line to be bisected, P must be smack bang in the middle. So BG bisecting means that it hits CH halfway along CH. This doesn't say anything about whether BG has been bisected, it says that CH has been bisected. So I'm not particularly interested in proving that BG has been bisected, but you can imagine with the cube it's going to be. Okay, now the way to do this is to try to create, this is the rule, create two journeys, going from the same start to the same place, but travelling along each of BG and CH. So essentially what you want to do is you want to find a way to get from B to P, travelling along this line, and you also want to find a way that goes from C to P, travelling along this line, but we need to have started and ended in the same position. Now the journey that I'm going to do is I'm going to go from B to P. Okay, and I'm going to go from B to P directly first. Now that will be using the line BG. It will use the line BG, and in fact it will be some proportion along the line of BG. Now some people might be thinking that, well, since we're assuming that, since we're going to be trying to prove that something bisects something, we can just say that it's going to be a half. So to get from B to P it will be half of B to G. You can't just say that, you have to prove it to be able to use it. And so what we're going to do is we're going to say that there's some scalar on B to G. Okay, B to P is some chunk of B to G. Now that chunk there has to be less than 1, and so what it will do is eventually we'll find out that K is equal to a half, and it will say that BP is a half of the line BG, but we don't know that just yet, so we're going to have to leave K as it is. Now we're going to need to find a vector for B to G. Now to get from B to G we're going to go negative B plus D plus H. So we're going to get negative B plus D plus H. That's the direction that I went. So for it to get from B to G we have to go along only vectors that we can know, and because this is a cube, A to H is the same as D to G, and so this would also be the vector H going from D to G. Okay, expand this out so that what you end up with is a set of coefficients to each of the vectors parts. Okay, so we've got negative K lots of the vector B plus K lots of the vector D plus K lots of the vector H. You'll see why that's important in just a sec. Now we're going to go from B to P, but this time we're going to try to use the other line that's part of this intersection. Now we've already used this line here. This time we're going to be trying to use the line from C to H. Now what I'm going to do is I'm going to go via C. So I'm going to go from B to C plus I'm going to go some proportion of C to H. We don't know what that proportion is just yet. We know that it's going to be a half if we've done everything right by the end of the question, but we can't just use that just yet. So it's going to have to be a different scalar. And now, for some reason, it tends to be K and it tends to be R. Okay, so we're going to have some scalar or some ratio of C to H. Okay, we don't know what C to H is just yet. We do know that B to C, though, is the vector D, plus we've got R of, well, C to H. To get from C to H, we could go negative D, negative B, plus H. Negative D, negative B, plus H. Negative D, negative B, plus H. Okay, and again what we need to do, similarly to what we did here, was to expand things and to get them to have coefficients to each of the vector parts that makes it up. Okay, so we've got for B, well, B would be made up, we've got negative R lots of B. That's fine. For D, we've got 1D and a minus R of D. So we get plus 1 minus R of the vector D, and for H we're going to get R of H. So what we've done is we've taken two different journeys to get from one point to the exact same point. So we're going from B to P directly, and we've also gone from B to P via C, which means that we get a chance to use each of the intersecting lines. Now, from the previous lesson, the very, very last question that I told you, which was really, really simple, these two represent the exact same journey. It is B to P. Since they represent the exact same journey and vectors only have a start and a finish point and a magnitude between them, then each of these coefficients to B, D and H must be equal to each other. So we now know that negative K equals negative R. That comes from the B coefficients. Negative K equals negative R, and so therefore K equals R. That's fine, it's okay that that happens. We know that from the H coefficients, we'll do the H ones first because the D one's more interesting. We know that K equals R from the H coefficients, which we already knew anyway. But from the D coefficients, what we know is that K is equal to 1 minus R. But if K is equal to 1 minus R and K is equal to R, then that must mean that R is equal to 1 minus R, which means that 2R equals 1, which means that R equals 1 half. Not only does R equal 1 half, K, because it's equal to R, also equals 1 half. Okay, now we're looking to prove that BG bisects CH. And what that will mean is that C to P to H must be 1 to 1. Okay, now to get from C to P, okay, from C to P, we set up here, it was this chunk here, this was the one we went from B to C and then from C to P. C to P is equal to R of C to H. Okay, it was R that splits up this line here. R is the ratio on that line, K was the one that went on that one. And so what we know is that C to P is equal to R of C to H. R is equal to a half, so C to P is equal to 1 half of C to H. Now, if C to P is equal to 1 half of C to H, then P to H must equal the other half of C to H. And so therefore you can see that C to P to H are in the ratio 1 to 1 because they're identical to each other. So therefore BG bisects CH. It's challenging, it's very, very, very challenging, but it's definitely interesting. The rule of thumb is create two journeys going from the same place to the same place. So in my case, I went from B to P. I went directly, so I could use the line. Sometimes people's inclination is that they'll use A every single time, but in this case you don't really need to. You can just go directly and take part of the line. And then find the other way to make that exact same journey using the other line, both of which need to have a ratio in there. Okay, now a bit more challenging is this one. A, B, C, D, E, F, G, H is a cuboid where D to A is the vector A, where D to C is the vector C, and D to H is the vector H. Okay, pop those on straight away, it's always a good idea. Now the vectors N to G and E to C intersect at the point P. You can see that N to G, E to C intersect at the point P. Point N is on the line A to E such that A to N to N to E is in the ratio 1 to 2. Now when that happens, if we've got A to E here, and we've got N there, this here is one chunk and this here is two chunks. It's in the ratio 1 to 2. Now what that means is that A to N will equal 1/3 of A to E. Okay, we should know that from GCSE really. So what we'll know is that A to N, that chunk there, will be 1/3 of H, and N to E will be 2/3 of H. It's important to get those on there early if you can. And we're going to be proving that N to P to G is in the ratio 2 to 3. Okay, where P is the intersection between these two lines. So we're going to try to find two journeys. Now the journey that I'm going to use first is going to be N to P. I'm going to go direct. Okay, now N to P directly will be K of N to G. Okay, K of N to G. It'll be some proportion, some scalar on N to G. It'll be some chunk along of it. Okay, now to get that we're going to have K of, well, we've got negative 1/3 H minus A plus C plus H. Okay, negative 1/3 H takes us there, minus A plus C plus H. Okay, remember this is a cuboid and so this vector will be the same as this vector. Tidy that up just a little bit and you'll get K, lots of negative 1/3 H plus a H will be 2/3 H minus A plus C, and then get it so that you've got coefficients of everything. And so we've got 2/3 K of H minus K of A. It's a good idea to put pluses in there and just factor the negative into the bracket. It makes things a little bit easier to go along with. Plus K lots of C. Alright, so that's NP directly. That there is one chunk of work, and that's really important to get. Next, we're going to go to N to P via a different route. So I'm going to actually go via E, which means I can use this one of the lines. I've already used this one. I'm going to use this one here. Okay, so N to P via E. Now that is going to be N to E plus some proportion of E to C. Okay, well N to E is 2/3 H plus some proportion of E to C. Well, E to C would be C minus A minus H. Okay, now in this case it's a little bit more difficult to get your coefficient parts. I'm going to try to match them in the same order as what I've got here, which is H first and then A and then C. So I've got 2/3 H minus R of H. So I'll have 2/3 minus R of H. For my A, I'll have plus negative R of A. And for my C, I'll have plus R of C. Okay? So the first part that we're going to do for the next bit is going to be, we're going to compare for vector. We'll do vector A because it's an easy one. So we've got negative K equals negative r, therefore k equals r. We're going to compare for C, which was k equals r, which is done. Okay, now that bit you do have to do that, it's important because it helps you to do the next bit. Now comparing for h, we've got 2/3 of k is equal to 2/3 subtract r. Now get just one variable in here, so we've got 2/3 of k is equal to 2/3 minus k. Alright, we're going to add on here, and so we're going to end up with 5/3 of k equals 2/3. So therefore 5k equals 2 and k equals 2/5. Now what we said was, originally we said that n to p is equal to k of n to g. Now k is 2/5, so therefore n to p is equal to 2/5 of the length of n to g. Now what that also tells me is that this bit here is 2/5 of the length, which tells me that this bit here must be 3/5 of the length. So therefore p to g must equal 3/5 of n to g. Okay, it must be the remaining bit, because when you add them up you need to be able to get an entire n to g. 2/5 n to g plus 3/5 n to g must equal 5/5 n to g, and so nothing's gone missing. Now n to p to g are, we've got 2/5 of ng and we've got 3/5 of ng. Cancel off the ng's, cancel off the fifths, and you get 2 to 3. Okay, and so therefore we've managed to prove what we were after, which is nice, it's fun. Okay, same rule though as the previous question, even though this one was more difficult. Find 2 ways to make the same journey using each of the intersecting lines. Factor out the coefficients, compare the coefficients, and work from there. That's all you'll be doing. Now it is challenging, it is difficult, but make sure you look at this video not just once, maybe twice, maybe 3 times to try to get your head around it if you can. Now your tasks are exercise 12C, page 347, questions 7 and 8. There's also a nice example in the book that I haven't used, which you can have a little look at as well. The extension is the challenge question, which is just after question 8, to have a little look at. Alright, it's difficult, it's not easy. There might also be some more of these to practice in the mixed exercise, so take a little look at them. But best of luck.